Hello everyone, I'm Tristan, I'm the co-founder and CEO of Escape, and we are glad to be there today at GraphQL Conf to present you the result of an exclusive research we did on GraphQL security, and more specifically, the vulnerabilities that exist in GraphQL APIs that are exposed online. I'm here today with my co-founder and CTO, Antoine, and we're glad to present this research to you. So first, to give a bit of context about Escape, we are the first automated API inventory and security testing platform. We have a specific support for GraphQL APIs, and we have a security research team that works specifically on GraphQL security. So for this research, we scanned about 1,600 production APIs, production GraphQL endpoints that were online, exposed on the internet. It took us more than 400 hours of computation time, so this is quite a big study. And we found about 50,000 security alerts on those endpoints, which represent about 30 security alerts per GraphQL app on average. So that's quite a lot of vulnerabilities that we found online. The result of this study is also available in a report that you can download online for free. It's the State of GraphQL Security 2023. I really encourage you to take a look at it if you are interested in the topic. There are a bit of exclusive research and results inside. So first, I will let Antoine explain to you why is GraphQL specifically vulnerable compared to classic APIs like REST APIs.
So thank you very much for this introduction. So indeed, you are all power users of GraphQL. GraphQL is now moving to enterprise and to every 4,500 verticals. It's an amazing technology, but it also comes with a lot of security concerns. Indeed, GraphQL, so it's a full-featured language, and it happens that every single of the features that you love using GraphQL are actually also a potential source of vulnerabilities. The second problem with GraphQL is that GraphQL organizes resources through a graph that connects everything together, which makes actually access control issues very common, and access control in general very, very difficult to handle on the graph because of the multiple paths leading to the same resources. So for example, here we can see that we have two different paths leading to the strike token resource, which means that access control is actually a nightmare. Okay, so now we had this small introduction about GraphQL and why this causing so many security issues. I would like to explain you how we came to studies and why it was hard to perform and why it's hard to test production GraphQL APIs in practice. So the first thing is that if you just send random payload to APIs, whether they are GraphQL or REST or anything, actually the requests won't be valid from a business logic point of view, and they won't pass the data validation layer, which entails that those requests that are actually malformed are not really able to test the application from a security point of view. This is why we created an unique in-house technology that is called feedback-driven API exploration that are able to build tailor-made requests that respects the business logic of APIs, and even more tailor-made sequences of requests that make sense according to the API that actually pass the validation layer, and therefore that can assess the security of GraphQL API in depth. Let's take the example of a random fuzzing method. So this is on your left. You can see that we could have injected random data on the API. This request, as you can see, is malformed and it won't pass the data validation layer. The one that we are able to generate automatically, and that allows us to discover what we are going to introduce you just after, is the one that is built on the right with coherent data. The first thing is that we re-inject data that is really present in the API, and that makes sense. For example, here we inject a real ID at the place of the user ID that really exists in the API. Instead of sending a random string or a random integer according to the typing that can be made. And we can see here at the password location, we managed to inject a real potential password with an injection attached to it and try to see if it can raise actually an SQL injection. Okay, the second problem, again, is that GraphQL is a graph. So when testing for vulnerabilities into GraphQL resources and GraphQL APIs, you have to make sure that you are actually testing the security of all paths leading to resources. This is really specific to GraphQL APIs, and this makes really complex to assess in depth the security of such APIs. Okay, so now let's talk about the findings. We found almost 50,000 security alerts. And it's actually, it happens that classic API vulnerabilities are still present in GraphQL APIs. I won't extend too much on those vulnerabilities, but they mainly, they are very common to any kind of APIs. For example, you can see that it happened in 12% of the endpoints that the debug mode is still enabled, or stack traces in general are actually leaking, and discloses very important information for potential attackers. And we can see that this is still very, very common in GraphQL APIs, while it was in any APIs. The other major problem are access control issues, and specifically we can see that we have almost 10% of endpoints that are actually misconfigured. Basically, they expose mutations, which means read and write routes without any authentication, which allows to make edits in the database without actually being authenticated, which is in most cases unwanted behavior from the developers and a real security concern. And of course, into the among the most common API vulnerabilities, there are injections, and we found actually quite a few real positive injections in the endpoint we tested, which still notice that injections are a problem today. So now I will let Tristan go more in depth into what really matters today, the vulnerabilities that are specific to GraphQL. So Tristan, up to you.
Thank you, Antoine. So exactly, what we noticed during this study is that there are some vulnerabilities that are common to all APIs, and they still exist in GraphQL. But what is specific of GraphQL is that it comes with its own kind of vulnerabilities, its own kind of security flaws. And those were the ones that were mostly present among production GraphQL endpoints. So we'll take a deeper dive into what exactly we found as security misconfigurations, as security flaws, as threats for production-grade GraphQL APIs. We found several kind of different vulnerabilities that affected those GraphQL endpoints, and we will take a deep dive into the main ones and the most critical ones, which are related to API brute forcing, denial of service, API schema leak, and unsafe public operations. The first top vulnerability that we found, and almost all the GraphQL endpoints were misconfigured from that point of view, come from the batching and the aliasing features of GraphQL. So you probably know about batching and aliasing in GraphQL. It allows to send multiple GraphQL queries in one single HTTP request, and it's very handy when using the language. But the problem is it can be used to actually bypass the rate limit if the rate limit has been done at the HTTP level. So I can send like 10 HTTP requests, but I actually sent 1,000 GraphQL requests in those 10 HTTP requests. So for instance, if there is a login mutation in my GraphQL API, I can try, like say, 1,000 combination of user names and passwords in one single HTTP request, and I can try to brute force the credential of people using this technique and still get under the rate limitation if it has been done at the HTTP level. But even worse, if you use this in combination with file uploads, you can create a vulnerability which we called GraphQL bombs. So this is a zero-day vulnerability that it has been found by one of our security researchers, and it combines the exploitation of aliasing and batching with file uploads in GraphQL. So how do you do file upload in GraphQL? Basically, you create a multi-part data request that contains the GraphQL query and also the binary data of the file in the same request. But now what happens if you send the binary data of the file, and instead of sending one single request, you send an aliased version of 1,000 mutation to upload the file that point to the same binary data that is existing in the request. Well, actually, if you do this, what will happen is that the server will copy 1,000 times the file that you uploaded when it unpacks the request. So you can send, for instance, a request of 1,000 times a 1 megabyte file. The request will be less than 2 megabytes in size, but when the server gets it, it will try to expand it into a 1 gigabyte request, and it will just crash. So using only a 2 megabytes request, we can create a 1 gigabyte file on the server side by using aliasing and batching on GraphQL. Imagine the problems that this can cause. So the consequences of having aliasing and batching not limited in GraphQL can be stealing user accounts, the exfiltration of sensitive data, and of course denial of service by exploiting file uploads. The second problem that we noticed that is very frequent in GraphQL is the exploitation of fragments to create denial of service. So you know it, fragments are like functions in GraphQL. It's a tiny piece of logic that you can reuse across queries in order not to synthesize the queries into specific parts. But what happens if you create a fragment that calls itself? Well, it's a bit like when you create a function that calls itself, it creates a recursion loop. And if there is no end to this recursion loop, well, you actually create an infinite recursion that can crash the GraphQL server. The biggest problem with that is that the crash happens at the server level, at the engine level, and not in your own code. So it's very hard to actually fix that problem. We will see after what solutions we have to avoid this happening in production. So the consequences can be denial of service and making the API unavailable with a simple request that contains recursive fragments. And finally, the last problem that we found that is very frequent is the internal leak of the internal GraphQL schema, namely the introspection schema. So you might know that GraphQL has a handy feature which is called the field suggestion. When you try to create a query and you made a typo in one of the fields or one of the queries, one of the operations, the GraphQL engine is very gentle and tells you, hey, did you rather mean create user or create file instead? Well, if you deactivated introspection, this still gives you information about the nature of the schema inside of the GraphQL endpoint. And you can actually use a tiny open source tool called Clairvoyance. And the Clairvoyance tool will randomly send plenty of operations and use the suggestions from the engine to build back the full introspection of the schema. So in this slide, you can see an example of a schema that we built back by fuzzing the GraphQL endpoint and getting all the information from the field suggestion. So you see, the schema is pretty big, and this has introspection closed. So the GraphQL engine does not let you have introspection, but still we managed to build back this full schema. And even worse, in this specific case, there was a mutation named update admin, and the GraphQL developers thought that it was hidden because they deactivated introspection, so they didn't add proper access control on it. So we were actually able to change the password of the admin user of this platform. Pretty bad, right? So the consequences of this vulnerability can be access to unauthorized function, and it can lead to further exploitation of other GraphQL vulnerabilities because it leads to understanding how the API works and what is the schema and what are the parameters that must be exchanged with this GraphQL API. Okay, so those were the technical vulnerabilities and the main technical vulnerabilities that we found during this study. But there is also something worse that we've discovered during this study of GraphQL endpoints in production. It's the amount of sensitive data that was actually leaking and made public through all these endpoints. We found about 5,000 potential PII and token and secrets leaks during this study. We found a lot of personal data, emails, phone numbers, passport numbers, bank account numbers, and other personal identifiable information that was leaking publicly through GraphQL endpoints. But even worse, we found a lot of API keys, like Amazon Web Services API keys, Google Cloud Compute API keys, private RSA keys, authentication tokens for various services, including Adobe, Asana, GitHub, and so on and so forth, from GraphQL endpoints. And remember that we did all this study sending only queries and never mutations, never things that were actually dangerous for the server, and we also never used any single authentication token. So all this study has been done by sending just unauthenticated requests on public GraphQL endpoints in a fully automated way. So if we take a look at the OWASP Top 10, which is the main framework that references the security of APIs, how does it apply to GraphQL endpoints? What we can see is that GraphQL has a lot of denial of service and complexity issues that are related to the unrestricted consumption of resources, mainly because by default, the GraphQL engines are very permissive in terms of the queries that they accept and the size of the queries that they accept. So this is due to GraphQL specific features. GraphQL has also a lot of access control, authentication and authorization related vulnerabilities. Why? Because GraphQL is a graph. In a graph, as Antoine explained, you have multiple paths leading to the same data, so you have to ensure the security of all those paths. And also the GraphQL specification does not say anything about authentication, so it's according to the developers of the endpoint to implement it properly. So this is related to all the kind of broken object level authorization, broken authentication, and so on and so forth in the OWASP Top 10 API vulnerabilities. And also, security misconfiguration and information disclosure are very frequent in GraphQL. Why? Because the federated GraphQL applications often forget to catch the errors of underlying APIs and send them back as is to the client, underlying internal errors, internal tokens, internal information. And a lot of GraphQL endpoints also have development features that are enabled in production. So before deploying a GraphQL endpoint, be sure to deactivate all the development features. So as a conclusion of this study, using only an authenticated API calls in fully automated mode by a crawler, we found 130K plus public GraphQL APIs in the wild, and we scanned 1,500 of them. We highlighted numerous vulnerabilities. Most of them were GraphQL specific, but not only. Classic API vulnerabilities were also there. And we highlighted that denial of services are very frequent in GraphQL and can be a single point of failure when using federated GraphQL. So if you use federated GraphQL, you are at risk of having your whole API federation being taken down if there is a misconfiguration that was let open to the public. So again, the result of this study is available in the State of GraphQL Security 2023. Feel free to check it out. It's completely free online. You can access it, and it gives a bit more data and more context about the specific vulnerabilities that we found in the GraphQL APIs. Before we end this talk and jump to the questions, two more things that are interesting to note. We created the open source security middleware GraphQL Armor in collaboration with several companies and teams that are here today, including the Guild. GraphQL Armor is a middleware that is free and open source. You can integrate it in one single line of code in your GraphQL engine, and it will provide out-of-the-box security best practices, mainly to protect against denial of service and information disclosure in your GraphQL endpoints. It's already used in production by a lot of companies, so feel free to check it out and contribute. We are happy to get more contributors for it. And the second thing, and this was released last week, so this is a very new project we released the first API Security Academy with a course on GraphQL security for developers. What is specific with this API Security Academy, first, it's free and open source, obviously, so you can add your own courses and collaborate on the courses. And secondly, it integrates a full execution environment in your browser. So your developers, when they go on the Academy, there will be a GraphQL server that exists in their browser in order to test the vulnerabilities and to fix the vulnerabilities in a live environment without the need to install anything. So this is a very cool and gamified way of learning about the security implications of GraphQL and how to harden your endpoints. This is the end of this presentation. Thank you for your attention, and if there are questions, we are happy to answer them. Yep. Yes. Yeah. So we use a homegrown tool. So again, as I said during my first slide, let me go back to it. So we are seeing the presentation again. Yeah, here. So our main job at Escape is creating an automated API security testing tool. So we developed an internal algorithm that is able to test automatically the security of APIs. And the particularity of this algorithm is that it automatically creates a relevant security test for any API. And this is the technique that we used during this study in a restrained mode in order not to mess with the normal behavior of the APIs.
And this algorithm requires no agent.
Oh yeah, it's the advantage of this approach is that we are fully agentless. This is why we can test a lot of APIs online without having to install anything in their production. Yeah? Go for it. Yes. Yeah. So it's for all JavaScript and TypeScript-based GraphQL engines, so mostly under the federation on the subgraphs. Or if you're using a JavaScript-based gateway, you can also install it in the gateway. There will be more to come about this soon. Any other question? Okay, so thank you everyone again. If you want to have a glimpse at the security of your own endpoints, feel free to come to us. We can start a tiny scan and see what comes up. Thank you everyone.
Thank you very much.